So very good morning everyone. Let's continue the chapter called Motion in a Straight Line. In this, a motion in a straight line chapter, the last session we are dealing today. Last session in this chapter, the last session we are dealing it. You know what is the last session? The last session is relative motion in one dimension. Relative motion in one dimension. This is the important thing. One dimension. This is the important part. Right? And there is a next chapter called a motion in a plane. In this chapter, we will be learning about a concept called vectors. After understanding these vectors, there will be a topic called relative motion in two dimensions. What is that? Relative motion in two dimensions. While discussion related to the relative motion in two dimensions, we will be discussing about one dimension once again. So then you will be understanding in detail. But in today's session, to understand this relative motion concept, you need the topic called vectors. As we have not done about the vectors, we are just learning the formulae related to relative motion in one dimension. It's a simple formula. Relative motion, it is also can be named as relative velocity in one dimension. Understand? Relative velocity in one dimension. Generally, the velocity we know. What is velocity? Which is a displacement by time. We know. If a body is moving in a straight line, I'm talking about if a single body is moving in a straight line, you know how to find its velocity, right? By using displacement by time. If it is the speed, we can call that as relative speed. Okay, we are talking about only speed. If it is a speed, if there is a single body moving with some speed, how you will calculate that speed? By using distance by time. That is a single object. When a single car, a single bus, a single bicycle is moving in a straight line, by using its displacement or distance covered divided by time, you can find its speed or velocity. Alright. But now the topic of our interest is relative velocity. Relative. When we say the term called relative. So there is a significance of the term called relative here. What is that? There must be a presence of minimum two bodies, right? So the significance of this term is, so the presence of a minimum two bodies, two cars, two trains, two persons, two bicycles, right? Two lorries, whatever it may be. So there must be a presence of minimum two bodies. Then only we talk about the topic called relative. Relative density. Density of a one object with respect to the other. Relative mass. Mass of one body with respect to the other. Relative height. Height of one person with respect to the another person. So that's called the topic called relative. So here same way relative velocity, right? So what is the relative velocity here together? I'm writing relative velocity is velocity of one body with respect to the other. Simple. velocity of one body with respect to the other body velocity. That's called relative velocity. It's so simple here. There are two cases involved in this, right? So what are the two cases? Let's understand. So the first thing is, this is the ground. So there is a body A and there is another body B. Okay. Well, this body A is moving in this direction with a speed VA or with a velocity VA. The body B is moving with a velocity VB. Okay. Now, the question is relative velocity of A with respect to B. Right? Velocity of A. What is this? Velocity of A with respect to B. So this is called the relative velocity. So the formula for this is VA minus VB. Remember, simple, VA minus VB when both the bodies are moving in a straight line. So this is the basic formula, and there is a derivation for that we are not doing it now. So that will be very easy for you when you understand the concept of vectors. First, remember, when two bodies are moving in the same direction, so the relative velocity is VA minus VB, right? For example, if somebody asks you to find what is the velocity of B with respect to A, formula remains same. When it is A with respect to B, so it's called VA minus VB. When it is B with respect to A, so it is VB minus VA. It's simple. Clear? Now, let's understand the another case. Another case. This is the ground. So there is a first body A moving with a velocity VA. There is a second body B moving with a velocity VB. Okay. Here, question is, what is the velocity of A with respect to B? That's called relative velocity of A with respect to B. So this is VA minus, you can see the formula remains same, VA minus VB only, but here VA and VB are in the same direction. Okay, so VA is in the direction, VB is in opposite direction, right? So that is why let me apply opposite sign here. VA minus of minus VB. So you get VA plus VB. So that is VAB. So velocity of B with respect to A also it will be VB plus VA. No confusions. Both are same. VA plus VB or VB plus VA. Okay. Clear? So look at this interesting part. Simple. When two bodies are moving in straight line, the relative velocity will be subtraction. When two bodies are moving in opposite direction, the relative velocity between them will be the addition. That's what the common observation you might have done, you might have seen, you might have made while moving in the train. When you are moving in a train, if you find the another train just beside you, right, beside you, this is beside your train, when you are identified a train just moving beside your train in the same direction, what do you feel? You will feel that the other train is moving slowly. In the same way, reverse the situation. You are moving in a train, imagine beside your train there is another train which is coming in the opposite direction. In this case, you will definitely feel that the other train is moving so fast because this is the situation. When both the trains are moving in the same direction, the relative velocity is subtraction. Your velocity minus the other velocity. So, you will see the other train is moving with lesser speed than it actually has. So, whereas in this case, what happens? So, your train is moving with one speed and the other train is coming opposite way with the other speed. When you are looking at the other train, so the relative velocity appears is what? Sum of your velocity and that train velocity. You will feel that the train is moving with a speed which is far greater than actually its speed. Okay, so that's a general example of the relative velocity. Now we have the equations of motion. V is equal to u plus at, and you can apply the relative velocity or relative motion concept here also. Imagine, let's take relative velocity of final relative velocity, initial relative velocity, relative acceleration. Time cannot be relative. Now this can be written final velocity of A with respect to B. Imagine, let's take this case only. Both will be moving some initial velocities. After some time, both will be acquiring some final velocities. They both move with different accelerations because speeds are different. Okay, so this is equal to UAB plus AAB into T. So what is this VAB? So it is VA minus VB, which is UA minus UB. Okay, plus AA minus AB into T. Like this way you can appreciate, we'll solve some numericals, then you will understand it very well. So this is the easiest way of learning relative motion topic in one dimension I am discussing with you. So in this way you can apply this relative motion with the equations of motion also. Right? So what is the other equation of motion we have? And let's write this. So we have S is equal to ut plus half at square. You can use the relative motion concept for this also. So we have a v square minus u square is equal to 2as. Let's apply the relative motion for this also. Right? Relative motion is not only for the velocity. Majorly we discuss about velocity, relative velocity, because most of the times the questions were asked from the relative velocity topic from this relative motion. That's why we majorly discuss about relative velocity. That's why these formulas. But relative distance, relative acceleration, relative velocity, questions can be asked any form, right? And commonly asked question in this relative velocity is simple. Let's look at this example. Simple. There is a ground here. Simple question, commonly asked. Carefully see. So there is a car here, right? Imagine it's a car A. So there is another car B. Car A is moving with the speed VA. Car B is moving with the speed VB. And initially both are separated at a distance D. Alright? Simple. Find after what time they collide each other. Find after what time they collide each other. And the difficult problems also, when there are two or more bodies are involved in a single question, the difficult numericals also you can solve easily. Within 2-3 steps you can solve by using relative motion topic. That's the importance of the topic of discussion. By using the relative motion in one dimension topic, you can solve lengthy problems within 2-3 steps. For example, there is a bus. The boy is at a distance D from the bus. Bus is moving and this boy is running. This boy is running to catch the bus. Bus is also moving. This boy is running to catch the bus. So bus is moving with some velocity, boy is running with some velocity, and there is a distance between these two bodies. After what time the boy will catch the bus? That's a question. Understand? So in this way also, what is the way of general solving of this question? First we consider the bus, the distance travelled by the bus, with what velocity it is moving. Next we consider the boy, initial velocity of the boy, distance travelled by the boy, after some time, All those things individually we solve the problem, and it takes so much time. I'm not saying that we could not solve, but we could definitely solve it. It takes a lot of time. Whereas in the same problem, if you apply the relative motion, within 2 steps you get the answer. Okay, let's have a look at this. Simple. Definitely they will collide. Will collide or they will cross. Right? These 2 cars will collide each other or they cross each other. So better. So let's think positively. Instead of hitting them each other, so let's think about crossing each other, right? Both the cars are cross each other. After what time they cross each other? So to cross each other, imagine this is the point where both are crossing each other. Imagine the distance covered by the first car is x, then definitely this car also could come here, right? This distance traveled by this is d minus x. See the interesting thing, my dear students. Together, to see the distance traveled by this car A to cross the car B is x. Distance traveled by car B to cross this line, which is d minus x. So both the cars together must cover what is the distance. So this is car x is covering distance, this is car d minus x is covering. So the sum of them, this first car distance covered before crossing and second car distance covered before crossing, and that is equal to d, right? That is equal to the initial distance between the 2 cars. So the point to be noted is to cross each other, okay, to cross each other, both cars need to cover distance d. Understand? Both need to be covering distance what? D. First thing. And the second thing is, look at here. The second thing is, what is the time? We know speed is equal to distance by time. Time is equal to a distance by speed. Time is equal to what? A distance by speed. What is the distance it is covered? Both the cars before crossing each other, d by speed. This is an important concept here. Here speed of not a single body. There are 2 bodies involved. When 2 bodies involved, I told you, you must need to apply a topic called relative velocity. That's called relative speed. As the 2 cars are moving in opposite direction, you know this is the case, second case. When 2 cars are moving in opposite direction, the relative velocity of one with respect to the other is addition. So this I will be writing as VA plus VB. Simple, that's it, that is the answer. You know, simple. 2 trains they might have given. After what time they cross each other? Simple, find the distance, to identify the distance given, divided by, check the relative speeds, that's it. Right, let's solve some numericals based on the relative velocity or relative motion now. Let's have a look at the first question. A train of length 120 meters travels at a speed of 57 km per hour. In what time it will pass a man walking 3 km per hour in opposite direction? Simple. Like 2 trains, so there is a train and a person. It's moving in this direction, and he is moving in this direction. So he is moving with 3 km per hour, train is moving with 57 km per hour. Both are in opposite direction. After what time they'll pass each other? Simple. We have the formula T is equal to d by the relative velocity, right? So what is that? T is equal to d. What is the distance between these 2? It's clearly mentioned. So initially this is not the situation, okay? So now a train of length 120 meters. So initially the person is not at here. So if this is the train, the person is here. So he is passing the train. That means he is covering the distance called 120 meter here. So 120 meter divided by relative velocity. What is the relative velocity here? As both the velocities are in opposite direction. So one velocity is 57 and this is 3. We'll add those because they are in opposite direction. So 60 kilometers per hour. That you can convert into meter per second. That is 60 into 5 by 18. Okay. And this I can also write 2 9s and 2 30s. Again 3 3s and 3 10s. So it's 120 by 50 by 3. So this is 120 into 3 by 50. So 0 0 gets cancelled. Right? Now here 36 by 5. So how much here? 5 7s are 35 and point and 1 is left 5 2. So 7.2 seconds is the time taken by this man to pass the train. Simple. Okay. Now, two objects A and B are walking with a speed of 6 km per hour and 10 km per hour respectively in the same direction. Find the relative displacement of B with respect to A. Relative displacement of B with respect to A. See, B is moving with more speed. Imagine both have started from here. As B is moving with more speed, so it is at this position after some time. A is moving with less speed. This is at this position after some time from the origin. Okay. So what happens after some time? So that relative displacement, that is the relative displacement here. Okay. Relative displacement of B with respect to A. It's so simple here. We have the formula. Carefully see. The relative displacement is equal to, what is that? Speed is equal to distance by time. Here it can also be written on velocity is equal to displacement by time. So the question is to find displacement. Let's take, it's a relative displacement which is equal to relative velocity into time t. So relative displacement is equal to relative velocity. What's the relative velocity here? So both are moving in the same direction. Relative velocity of B with respect to A. So B is 10, A is 6. Relative velocity of B with respect to A is 10 minus 6, it is 4. You should understand one important thing, it is kilometers per hour. Okay. So it is 4 kilometers per hour into time. Time is given here after 4 hours. Okay. So this is 4 hours. So I can say 4 into 4. 16, we are finding displacement, so that is kilometers. So what is the answer we got? 16 kilometers. Let's have a look at the another question. Here, there is a bus moving with a speed of 10 meters per second, my dear children, on a straight road. A scooterist wishes to overtake the bus in 100 seconds. If the bus is at a distance of 1 kilometer from the scooter, right? So the diagram, the basic simple diagram, let me draw here. So this is the basic simple diagram I am drawing. So there is a scooter here and there is a bus here. So they are initially at 1 kilometer, means 1000 meter distance. Bus is moving with a speed of 10 meters per second. Scooterist wishes to overtake the bus in 100 seconds, right? So in how much seconds he is going to overtake the bus? 100 seconds. If with what speed, look at here, this is the speed of the scooterist. In 100 seconds, if he want to overtake, imagine he overtook the bus. In 100 seconds, in that case, what is the speed with which he should move so that he will chase the bus? I've told you already, the formula to be applied here is S is equal to ut plus half at square, my dear children. It is relative and this is relative and this is also relative. S relative. First concentrate on S relative. What is the S relative between these two here? Which is 1000. Okay. Which is equal to U relative. We are talking about speed should the scooterist chase the bus. Relative speed of the scooter with respect to bus. So that is U minus 10. Understand? So both are moving in the same direction. I can say this speed minus this speed. That's what the relative speed of scooter with respect to the bus. Into time. In what time it is happening? 100 plus half into relative acceleration. Acceleration of the scooter minus acceleration of the bus. As this is moving with constant velocity, acceleration is 0. And this is also moving with constant velocity, acceleration is 0. So now acceleration is 0 into a t square. So this part will become 0, right? So then I can say it is 1000 divided by 100, so which is u minus 10. So two zeros, two zeros. Minus 10 comes to the other side, that will be plus 10. So you get u is equal to 20 meters per second, my dear students. In this way, the commonly asked questions are there. And let's solve some more questions based on the relative velocity topic. Let's have a look at some more numericals. Two cars are moving in the same direction. Two cars are moving in the same direction with the same velocity of 30 kilometers per hour. They are separated by a distance of 5 kilometers. Let me draw you the basic diagram. So this is the track ground. Two cars. This is car 1. This is car 2. Both are moving with the same velocity. What is that? 30 kilometers per hour. Now, they separated by 5 kilometers. Okay, or 5 kilometers. A truck is moving in opposite direction, meets the two cars in an interval of 4 minutes. What does it mean? From somewhere, so there is a truck is moving in this way. It will reach the second car at 0 seconds, for example. By the time this car will come here, whatever it may be, the truck is passing through or crossing the first car in 4 minutes. Look at here carefully. The time interval of meeting both the cars is 4 minutes. Imagine when it is meeting this car at 0 seconds, so it is meeting the other car at 4 minutes. So, what is the distance traveled by the truck from here to here? It's 5 kilometers. Right? What is the time interval from here to here? 4 minutes. And what is the relative speed from here to here? Truck is moving in this direction. So this car is moving in this direction. So with a speed of 30 kilometers per hour. Now what is the question, my dear students, here? What is the velocity of the truck? If you imagine the velocity of the truck is v suffix t, then you know distance is equal to speed into time. So simple, right? So let's have the distance. What is that? 5 kilometers, which is equal to speed. Speed is how much here? Relative speed. So this car 1 is moving with the speed with this 30. This truck is moving with the speed Vt. So Vt plus 30. So this is kilometer per hour. This is kilometer. I am not changing any units here. Into time. Time is given 4 minutes. 4 minutes. So this need to be converted into the hours. So because this is in kilometer per hour, this is in kilometer. So let's convert this into the hours. Now, this is 6 5s. 300 is equal to 4 Vt plus 120. So 300 minus 120. So it will be 180, which is equal to 4 into Vt. This is 4 4s, 4 5s. So what is the velocity of the truck here? It's 45 km per hour, my dear students. Do you understand this? Is it simple? By using the relative motion, the simplest way of solving. See here, 3 bodies are there. I told you the minimum number of bodies required to solve the concept, to solve the questions based on relative motion. 2. But here, car 1, car 2 and the truck. In this way, questions will be asked. Alright? And this is the question, it's the most interesting question of the session. Okay, so and this is the last question of today's session and the last question of this chapter. Right? By today evening, you will be getting an assignment based on motion in a straight line. Almost 40 to 50 questions, right? I'll give you to solve you as an assignment. Now, listen. That assignment is other than this 10 questions online exam. Okay, that's apart from that. Your 10 online questions are there. Your online exam is there. Look at here. There is a train which is moving with 37.5 kilometers per hour. There is another train which is also moving with 37.5 kilometers per hour. Both are moving opposite to each other, means towards each other. Initially, there is a gap of 90 kilometers between them. Read the question. A bird is flying to and fro between the trains with a speed of 30 kilometers per hour. See the interesting thing? There is a bird here. There is a bird. It's moving to and fro like this, in this way, in this way, in this way. Just keep on moving. There's no other work for that, right? Simply it is moving forward and coming back. A bird is flying with a speed 30 kilometers per hour to and fro between the trains. Now, find the total distance traveled by the bird before the two trains meet each other. As it is making to and fro motion, at the same instant, the trains are getting very closer. Yes or no? The trains are coming very closer. Trains are getting very closer. At one instant, it cannot do to and fro. It will fly off, otherwise it will die. Yes or no? So, till the time both the trains reach to the meeting point, how much is the distance traveled by this bird? That's the question. Is it interesting? 100% it is interesting. That's it. Forget about the bird now. You know simply what is the time taken by the two trains to meet each other, right? Because that much time it will make to and fro motions. Okay. The same thing I write here. Time taken by the trains to meet each other. So this is the formula we know already. T is equal to D by V1 plus V2 because both the trains are moving towards each other, right? So D is 90 kilometers by V1, V2. 37.5 plus 37.5. How much it is? So it is 35 plus 35. It's 70. So it is 75. right? So T is 75. So let us write it in terms of, for your better understanding, let's write it in terms of, okay, keep it here. So what is this time? You get it in hours. Now, find the total distance traveled by the bird before the two trains meet each other. Now let's concentrate on the bird. We have the formula speed is equal to distance by time. So we need distance traveled by it. Okay. So the distance traveled by the bird is equal to speed into time. So what is the speed? Speed of this bird. With the same speed it is moving, right? So it is 30 kilometers per hour. Everything is in kilometers per hour only. I am just keeping it as it is. Into, right? Or that's right here. So 30 into kilometer per hour into time. What is this time? Is this the time which is just found? So what is the time? Time taken by the two trying to meet each other. The same time only the bird will flies to and from ocean, right? So this is the time which is 90 by 75. Okay, clear? So what is this 90 by 75? It's hours. So hour cancel here, right? So this you can continue here. So 5 1 5 2s, right? 5 1 5 5s, 5 6 15 6, yes, 36 kilometers, my dear students. Understand? So in this way numericals also will be asked. So this is how we have solved the chapter, and we have solved the questions, and we have finished the chapter, right? Now we will be starting a new chapter in the next class. And before that, try to solve the assignment what I'm going to send you by today night. All the very best for your online assignment.